So good afternoon once again. We're going to continue our discussion on time series analysis. In particular, we would like to make use of the ARIMA modeling because it's a very helpful and useful tool as far as time series analysis is concerned. Now, what we did last time was we downloaded the Apple dataset, gave it a name, AP, okay, and we set the date from January 1, 2015 up to the end of December of 2023. And then what we did was to we got the the adjusted price of the stock. So let me just go there. Okay, here class. What we did was to subset, got the sixth column. This is the adjusted price. Okay, and then after that we got the returns, the log returns. Okay, so we looked at several ways to get the log returns, and the easiest is, of course, you can either use the return.calculate or calculate returns from the performance analytics package. So if we want to get the log returns, as in this case, I think we use the, okay, LAP-RET. Okay, so we learned several ways to do this. One is the return.calculate or calculate returns. Just make sure that the method is equal to log. Okay, here, method is equal to log. And then we omitted the first observation because that's an NA value. Or we could have used the NA that omit the diff log of the object. Okay, getting the difference after getting the log, you get the log first and then get the difference. You're actually getting the log returns. So this is similar. This one is similar to what you'll be getting from this one. Okay, and we have shown that last time. Okay, so any questions about the getting of the returns? May I have your confirmation class, your chat, please? If so far clear tayo dun sa, if we're clear as far as getting the returns, whether it's discrete returns or log returns. Okay, good, thank you. All right, thank you so much for your feedback. Okay. All right, that's good. Okay, and then what we did was to determine if the data, the log appret is already stationary, okay? And we plotted that one last time, and we said that indeed this is stationary. It's stationary in mean and stationary in variance. In mean because there's no trend. In variance because there does not although there are what we call volatility clustering, okay, in some areas here, but it doesn't seem to show an increasing variance or a decreasing variance over time. Okay, but we said that there's a way to check this statistically, and what we did last time was to use the from the T series package, we use the ADF.test. Okay, so let me just review this. Let me run this again. Okay, so now I'm going to remove this. Okay, this is wrong already, class. No? Now, why is this wrong? Because the log AP-RET, we already removed the first missing value. So if you're going to do this, we are going to remove again the first row, which is not an A, class. Okay, so let me just clarify this, class. All right. So let me just do this LAP-RET. Okay, my LAP-RET class, this one is not, this is not a missing value. So if I run the one that I deleted again, if I run it, then it would have removed the first row. it would have deleted the first row, sorry. Okay, so let's use this test, augmented Dickey-Fuller test. This is a test used to determine if your time series is stationary. Okay, so we have here, it tells us that the null hypothesis is the time series is not stationary. And we can deduce that from the alternative hypothesis, which is that the time series is stationary. Okay, now since the p-value is 0.01, then we reject the null hypothesis that our time series is not stationary. We reject that. Okay, we reject that. There is no reason to believe, there's no statistical reason to believe that our series is not stationary. Right? Any questions with this class? Again, let me pause for a while and ask you once again for your feedback if clear yung test na to, no? Itong augmented Dickey-Fuller test, ADF that test. Okay, good. Thank you. How about the others? Waiting for the others to give their feedback. Okay, thank you. There are other tests, and one of them is, for example, this from the URCA package. Okay, let me, I don't know if I have shared this with you. Let me share the others. Let me see if I can copy this. Okay, good. And up to this one. All right. So aside from the ADF that test, there's the KPSS test, and there are other tests like URDF that test. So let's take a look at this. This is a more informative test coming from the URCA package. Okay, there are three types that's discussed here: none, drift, and trend. Now, we will not be discussing this anymore, but I would hope that you look at the documentation of what this means, no? Yung none, drift, at saka trend. So in this case, the default is none. But anyway, I typed here, type is equal to none. All right, then logs, this should be equal to logs is equal to 1. Okay, so kindly type log is equal to 1. Okay, and then let's run this. And we have the test here. So augmented Dickey-Fuller test, unit root test. UR means unit root. And when you say that a time series has unit root, it means that it is not stationary. Okay? Unit root means that the time series is not stationary. Okay, so the test here is just like the ADF test. It tests whether the null hypothesis is that the time series is not stationary. Okay, so if you take a look at this one, what's important for us are this ones, the test statistic and the tau, which are the p-values, t values, I mean the tau values. All right, so our test statistic is negative 35.06. And the critical value at 1% is negative 2.58. At 5%, it's negative 1.95. We can just use the 5% level of significance. And you can see, if you compare the test statistic, it's negative 35, and our 5% is negative 1.95. So if you plot the rejection region, okay, our test stat is to the left, okay, to the left of this value, negative 1.95. So what does that mean, class? It means that, so maybe I should draw that. Just like the test that we did before, class, and I hope that it's quite clear to you already. So this is what we're testing. This is our t distribution. Our critical value is here, negative 1.95. This is using a 5%. This is a 5% level of significance. And our t value is at here, negative 35, okay, which belongs to the rejection region. Okay, so what's the null hypothesis? It's the same as your ADF test. It's that the time series in consideration, which is your log AP ret or log Apple returns, has a unit root. It has a unit root. And what does having a unit root mean? Having a unit root means that our time series is not stationary. Okay? So our conclusion here, our inference is that we reject this null hypothesis that our time series log Apple ret has a unit root. Okay? Again, class, anong ibig sabihin ng unit root? A unit root indicates that our time series is not stationary. Therefore, we reject that. And our inference is that our time series is stationary. Okay. And we also saw that in the plot of the log returns. Okay, so let me pause again for a while, and may I ask your confirmation if you're able to follow the discussion using the URCA package class. Okay, the UR.df. If you're in your in your case, it does not run, then I suggest that you install first packages na URCA. So install na lang kung wala pa si URCA there, unit root, and co-integration test for time series. So yung UR done, unit root. Okay. So again, may I request your confirmation if you're able to follow. Okay, good. Thank you. Thank you so much for your feedback. All right, now that we have determined if the time series is okay, first we have prepared our data set, our time series. We said that we're interested in modeling the returns of Apple. We're not actually the returns of the Apple adjusted prices. We're not modeling the price of Apple. Okay, so please remember that distinction. Okay, if we were modeling the Apple prices, then we would have used just the Apple closing. Okay, here we would want to model the returns, and usually, class, if we're modeling the Apple prices, then it would not have been stationary. Then we would have done transformation with it. But if we were doing the returns, whether it's the discrete returns or the log returns, okay, let's see. Why don't we do this? Let's go back here, class. And here, okay, if you recall, class, appret 2, okay, this is delt of AP. Delt gives us this gives us the discrete returns. Okay, so if I run this, okay, and okay, so if I look at Apple ret 2 here, there will be a NA value here, right? Missing value. Okay, so I'm going to put here also NA.commit, and then put here true. Okay, and then once again check AP ret. Wala. Oh, sorry. I-print ko ulit. No? Hindi siya nag-automatic na. Alright, so no more missing value. And if I plot, sorry, just put it here. Plot of AP ret 2. There you go. I will see that this is also stationary. AP ret 2 there. It's also stationary. Okay, so whether you use discrete returns or log returns, it has it usually converts your data Okay, because if you recall class, yung plot ni AP natin, yung Apple prices, hindi ano to, no? Hindi siya stationary. Okay, so that we cannot directly model AP with ARIMA. We will have to transform this by converting it into a stationary data time series. Okay, we'll go back to this later on. So just a summary of steps in determining the ARIMA model. Quick summary lang to class. Okay, so what do we do class in order to generate an ARIMA model? Number one, of course, you plot the time series. Of course, you download it, you load it to R, and then check if it's stationary. So if not, you will have to do some transformation. Okay, if it's not stationary in mean, which means there's a trend, so what you can do is difference the data. Differencing the data will cure that the trend. Okay, let me go back here to the example a while ago. Okay, so remember that the UpRet 2 is, sorry, AP is not stationary, right? Okay, how do I now address the non-stationarity of AP? I can create this object DAP, control N, and then NA.omit, and then diff AP. And then I put here 1, 2. Okay. So what am I doing, class? I'm demonstrating here that by getting the difference of your non-stationary object, in this case, AP, ano nangyari? Pag dinifference natin siya, tapos plot ko, plot DAP, what happens, class? All right. So you can see here now that the difference of your Apple series is, well, it looks like that medyo may ano, no, may konting increase ng variance. No? So perhaps it treated the non-constancy in mean. Okay. However, perhaps it did not treat the non-constancy in variance. So if we check this class using the ADF test, if you recall ADF.test of DAP, let me just check if this is stationary already. Okay, then what does this tell us, class? All right, anong ADF test dito? Let me use the ADF na, kasi maraming ADF test, no? Let me use the ADF test coming from the T-series class. It's possible that this is another ADF test. Let me just use the simple one coming from the T-series function, T-series package. Okay, let me put it here, Control B. Okay. All right, so this is the simpler result class. All right, so still with the p-value equal to 0.01, okay, and with the null hypothesis that the time series that DAP is not stationary, we reject that null hypothesis. So even if the plot of DAP seems to point to non-stationary invariance. Hello, class. Hello. Did I lose you? Hello.
Yes po.
Nawala?
We got disconnected, sir.
Matagal ba?
No po.
Then, okay, sige. Thank you.
Saglit lang din, sir.
Saglit lang, oh. Buti na lang. Kasi medyo nagloloko talaga tong connection ko dito. I don't know, maybe it's because of the Ethernet or whatever. Okay. I just hope that the recording did not stop. But if it stopped, class, anyway, I'll be having another class, so I'll make sure that the video is also shared with you. Okay, so let's go back to what we were discussing. Okay, did you see this class? The one that I discussed about the difference AP. Class, kindly tell me if you missed out on this. Class,
Hello, sir.
yes.
Your screen is not being shared.
All right, sandali ah. Okay, this one class, yung difference ng AP. Did you get that or you missed that part? Sige, ulitin ko na lang, no? So, as I was saying, class, the data that we're looking at is the log of Apple, no? The log returns. Now, why that, class? Because usually that's what's being modeled as far as financial time series is concerned. Okay, but in the event that you'd like to model the AP, the Apple, the adjusted prices of Apple, you can do that also, class. And as I said, if we plot Apple, you notice that this is not stationary. So you cannot directly model this. You will have to transform that data. So how do you transform that? In order to make it, since there is a trend, how do you detrend? Okay, how do you detrend it? When I say detrend, how do you remove the trend? Our Apple data behaves like this. There's a trend, right? So this is not stationary. So how do we deal with this non-stationarity? You'll have to transform the data by removing the trend, or you have to detrend it. Remove the trend or detrend. So how do you do that? One of the easiest ways is to get the difference. Okay, which means you have the price at time t, you have the price at time t minus 1. Okay, you just get the difference, p sub t over p sub t minus 1. Okay, then you have now a new time series, a difference time series. Now, sometimes it might not become stationary in one differencing. So you now have a second order differencing, right? This is your difference data set. Okay, then you do another differencing. Okay, so once again, you difference this one minus this one, etc. So that's an order two differencing. Okay, but usually just with one differencing, okay na yung data natin. Natatanggal na yung trend. Okay, so this is what happened here. What I did a while ago was to difference our AP, NA.omit is equal to true to remove the missing value. And then I plotted it, class. And then I got the DF test. Okay, let's see. I got the augmented decay Fuller test to see if this is a stationary time series. So if I run this, okay, and plot it, we get this. Okay, we got this. So definitely there's no more trend, but we're not sure if this is constant invariance, okay, because of the volatility clustering in the future dates. Okay, but we can check it statistically based on the augmented decay Fuller test. So we test DAP, and I said a while ago when I got cut, I think, that again, the null hypothesis here is that the time series has a unit root or not stationary. And since the p-value is 0.01, we reject that null hypothesis that the time series is not stationary. So DAP is stationary. Okay, so you can now work on this. You can now model the difference of the Apple return. Okay. All right, so let's go back to where we are here. Okay, so take a look at step 2 and step 3. If the data is not stationary, okay, you can first, if it has a trend, okay, and if it's constant in variance, okay, for example, again, let me plot our data. An example is this one, class. Suppose our data behaves this way. This one. So it has a trend. So that's why it's not stationary in mean. However, it's stationary in variance. Okay, because our data is not its variance is not behaving this way. The variance is not increasing over time or decreasing over time. The variance here seems to be constant, no? Dito sa series na to. Okay? So, how do you make this stationary? Difference lang. Okay, just difference it. Okay, and then it will almost always treat the non-stationarity in mean. Okay? However, if our data is behaving this way, and may funneling out yung data natin, or funneling in pag ganun yung data natin. Okay? Then, we have a problem with the variance. So this is not stationary as far as variance is concerned. So to address that, what we often do is to get the log. Okay? Get the log of the data. All right? So if the data is not stationary in mean, then just get the difference. If the data is not stationary in variance, but it does not display trend, then just get the log transformation. However, if the data is both not stationary in mean and not stationary in variance, so suppose our data is behaving this way, ayan yung data natin, no? Okay. So medyo may trend at saka medyo may non-constancy in variance. Then you'll have to do two things, no? You'll have to treat the non-stationarity in variance and also in the mean. So what you have to do first, if you're going to do both, then you have to take the log first and then get the difference. Okay? You cannot get the difference first and then get the log, because getting the difference would introduce potentially negative numbers. And if you have negative numbers, you cannot get the log anymore. Mag not a number tayo dyan, mag-error tayo dyan. So first get the log and then get the difference, which is what we did in our data set. Now, why did we get the log? It's because the model just dictates that we want to get the log returns. Okay? We were modeling, what we want is to model the log returns of our time series. So that's why we had to get the log and then get the difference to get the continuous returns. Okay? So the reason why we get the log and then get the difference of our time series is because we're looking at continuous returns, continuous ret. And to get continuous ret or log returns, you have to do this process. Get the log and then get the difference. And that's exactly what is done when you use the return that calculate or calculate returns. Okay. So once we have addressed this class, okay, we can now double check again if it's if the data is stationary. Okay, getting the log and getting the difference, you have to test again, check visually if our data is stationary, and then check statistically. Okay, check statistically class, and we have done this already. No? We also did here yung URCA, no? UR.df test. All right. So we did the ADF test, we did the KPSS test, we did the UR.df test. All of them point to the fact that our data, our time series, our log returns is stationary. Okay. Now the next step class is step 6 here. Actually, this should be 6A yata dapat to, sorry. And this should be, ano ba to? 6A. Okay, anyway. Maybe here 7. Let's just make this 6A and 7. Or 6-bit na lang to. Okay. All right. So, before class, so we're now on the threshold of creating an ARIMA process class, an ARIMA model. So how do you do that? Before, you had to plot manually the ACF, which is the autocorrelation function, and the PACF, partial autocorrelation function, to determine what ARIMA model to use. Now this, manually, this is very, very, very tedious, no? Matagal tong process na to kung magma-manual. And believe me, it's not a fun process. So, ngayon, mabuti na lang may ano na, may mga packages na tayo in R. But why do we have to plot the ACF and the PACF, the autocorrelation function and the partial autocorrelation function? Ito muna class, yung autocorrelation, as the name suggests, kukunin mo lang yung autocorrelation ng log 1 and then log 2 and then log 3, etc. So in other words, class, if this is our data, let me go here. How do you get the autocorrelation function? Simple lang. Okay, this is our data. Diba? Ito yung data natin. Right? I'm starting from the most current, no? Ito yung data natin, di ba? So what we do now to get the autocorrelation at log 1, ito class, kukunin natin, ilalagay natin to dito, no? Kukunin natin yung log 1. Okay? And then we will get the correlation. Ano yung correlation nitong data na to, yung original data at saka yung log 1? That will be your autocorrelation for log 1. As the name suggests, class, auto, no? Self. We're getting the correlation of the data itself with itself. So if you get class, if you create a log 1 series, so ito pupunta dito sa second, etc. I hope you got what I mean. No? Ito pupunta dito. And then compute for the correlation of this original with the log 1, you get the autocorrelation at log 1. And then, pwede mo kunin log 2. So log 2 class, ito naman, itong second log, pupunta dito ngayon sa una. No? Okay, and then ito pupunta dito, etc. No? Etc. So you get the autocorrelation, the correlation of that, then you get the autocorrelation at log 2. And then etc. At log 3, at log 4, etc. So that's the autocorrelation function. Okay? Si partial naman class, si partial autocorrelation function, nagre-regress tayo, no? You do a linear regression. Okay, linear regression ng log 1, log 2, log 3. Okay, so in other words, class, meron tayong function dito, beta null plus beta 1 times x sub t minus 1 plus beta 2 times x sub t minus 2 plus beta 3 times x sub t minus 3, etc. etc. Yung mga betas dito, class, yung mga parameters that is generated, okay, so of course this is x sub t. No? The betas there that are generated via a linear regression model are called your partial autocorrelation functions. Okay? Partial siya, ibig sabihin, partial contribution niya dun sa modeling ng x sub t. Okay? So we now have, then if you have the autocorrelation function for log 1, for log 2, for log 3, and then you have the partial autocorrelation for log 1, log 2, log 3, etc. Then you can now create your autocorrelation function and partial autocorrelation function. Okay? The good news is, class, hindi natin kailangan i-compute yan manually kasi pwede na nating i-compute yan via R. Okay, so let's go. Let's go here. All right. So dito na tayo sa sa step number 6, no? Okay? So sabi ko dito, the old way to determine kung anong klaseng ARIMA model to, ang data natin, is to plot yung ACF at saka PACF and to determine which ARIMA model to use. Kasi the ACF and the PACF will now give us a hint. It will now give us a clue kung anong klaseng model yung gagawin natin. Okay. Let me share with you here. Okay. Dali, no? Hindi, sige. Ano yung kumunto, class? Quickly, tapusin ko na tong summary na to. Tapos gawin natin, ituloy natin sa LAPRAT natin. Now, pwede rin class, pwede rin hindi na natin i-plot. Although useful pa rin yung pag-plot. Kasi class, magkakaroon kayo ng idea kung ano kaya yung model. in your case, class, you will have to plot the ACF and the PACF. However, you will not determine manually kung ano yung ARIMA model natin. What you can do is here in step B. Okay? Ito, 6B. Determine the ARIMA through the auto.arima function. Yan. So merong function sa forecast package, no? Yung auto.arima. And it really gives us the model. So automatic na class. No? So kaya itong ARIMA medyo parang straightforward siya. No? Straightforward na na modeling. And then after that, step 7, after you get the model, you may forecast the time series. Okay? Or yung iba, I think balik na dapat to, no? Control X. So bago tayo mag-forecast, tingnan muna natin kung acceptable yung model natin. Pakibaliktad na lang class, step 7, and saka tayo mag-forecast kung acceptable yung model natin. Alright? Okay, so let's review what we have done so far. Okay? So, ito muna, class. Control C. I'll share this with you in the chat box. All right, so we have done actually steps 1 to 4, no? We downloaded the Apple prices, we subsetted the adjusted price, and we got the log returns kasi ang gusto natin i-model yung log returns ni Apple. And then plinat natin class, 'di ba? Ito yung step number 4 din natin, no? Plinat natin, and we saw that based on statistical analysis, ito yung time series natin is stationary. Okay? So pareho, no? Pareho. We did this just a while ago. Sinare ko sa inyo itong code na to. Okay, hindi ko na isi-share ulit, ha? Alright. We saw that even at the 1%, the 5%, at the 10% level of significance, significant yung ano natin. We conclude that our time series is stationary. Alright. Now, how do we plot, class? How do we plot? So in the interest of time, i-share ko sa inyo yung code na to, pero yung pangalawa hindi. Okay? All right. So we're going to make use of the forecast package. Sa forecast package, merong function na ACF there. Okay? Autocorrelation function. And then what autocorrelation are we doing, class? Yung object natin, yung LAPRET. Meron din siyang partial autocorrelation function. Okay, so we identified the returns, the object that we're interested in, and then linagyan ko lang dito ng title, no? Main is equal to autocorrelation function for, mali ito, no? So this should be, paki-change lang class, log AP ret. So this should be for the difference na log. Difference na log series. Ito din, difference na log series, and this should be, gawin ko lang yung ano, LAP ret. All right, sorry for the wrong title. All right, so ito yung function class, ACF and then the PACF. Let's run this first. Let's run this. Okay. And what do we see here? Okay, tingnan nyo to class, no? Hindi lang maganda masyado yung ano, no? Nawala yung pangalawa. Minsan biglang nawawala yung ano eh. Okay. Anyway, class, what will this give us? You can see here, class, ito yung autocorrelation function at saka yung partial autocorrelation function. And then you can see here the blue dotted lines. Okay. Any spikes outside of this blue dotted line means there is a significant correlation. For example, ito class. No? So this is 1. Okay, this is 1. So lumabas siya ng blue line na to. Ibig sabihin nun, may significant correlation yung LAPL ret natin. No? Okay? Sa log 1 at saka yung sa original data na log ALPL ret. And then you can see that yung longer lugs natin, ito, 7, 8 yata to, or 6, 7, no? Significant din. Significant din to, significant din to. So yung mga larger, longer lugs natin, mukhang may autocorrelation pa rin. Okay, ito naman class, tingnan nyo, partial autocorrelation function. No? So ito din ganun. Si PACF, merong significant, no? Na partial autocorrelation. And ganun din sa iba. Although sa iba, wala na. No? Why? Kasi hindi na sila lumalampas dun sa blue dotted lines. Alright. Now, another way to plot this, kasi hindi medyo maganda yung pagka-plot dyan, is this one class. So pakiran nyo to, no? Si AC, autocorrelation. So this is yung AC natin, if you recall, AC. Okay, this is from the TSM package. Ito yung nahirapan tayong i-load, no? So, okay, magagamit na natin dito yan, no? Ito. But let me just put it here, TSM. Okay, for you to know, saan galing tong AC, autocorrelation function. So if you run this, maximum that log, you can make this 12 or you can make this 18. So this is depende sa inyo, no? Usually hindi naman lumalampas ng 24 or minsan 18 nga or 12. Kasi you might not be interested anymore in the autocorrelation dun sa 24. Importante in 24 or 20 or maybe 12 or 24 kung may seasonality. Kasi kung may seasonality, then magkakaroon ng significant correlation between, kunyari, yung log 12 at saka yung log 1 or log 0. No? Okay. If you run this class, you'll get this. So this is the AC. No? And just like a while ago, mas clear nga lang to kasi side by side. No? Makikita natin may mga, sa autocorrelation, may significant correlation at log 1. Tapos meron din, mukhang meron sa log 7, log 8, log 9. Tapos yung yung mga later logs na mukhang wala na, no? Except meron ditong sa 22 meron, no? Pero mukhang hindi naman ganun. It doesn't look like that strong correlation. Ganun din sa PACF, yung partial autocorrelation function. Okay, anong gamit nito, class? Before class, nung wala pang auto.arima function, magta-trial and error tayo. I-determine natin ano kaya to, no? Based on the PACF, ano kaya to? Anong model? Is it an AR1 model, an MA1 model, an ARIMA1 model, etc. So yun yung trial and error class, no? That's the trial and error thing that we do before, no? When we after plotting the ACF and the PACF, para ma-determine natin kung anong model. Remember class, yung beginning with the end in mind, what we're trying to do here is we would want to determine kung anong model natin for our log AP-RET object. Okay, yung log returns ni Apple. Okay, ano kaya magandang model dyan? Kasi we would like to predict, for example, yung returns for the next, let's say, 22 days, for the next 1 month, kasi daily yung data natin, etc. No? Or the next week. Okay, kasi one of the capabilities of this is that we can predict, no? Pwede natin ma-forecast, which is your number 8. Step number 8 natin yan. Okay. All right. So, were you able to run this class? Were you able to run that? Paki-chat naman please kung na-run nyo yung AC function. Okay, good. Thank you. Waiting for the others class. Okay. All right. Thank you. I hope the others are able to follow along. Now, ang question, anong model to? If we're going to base our model on the ACF and the PACF, then we need some guidelines. So let me share with you some guidelines here. You may, there are many other guidelines, class. You can just use this as one of the many guidelines that we can use. Yan, okay. Ito yung class, no? Interpreting the ACF and the PACF plots. Okay, so I'll leave you to read this. Okay, sa ilalim class ito. Ayan. Identifying AR, MA, ARMA terms with the ACF and the PACF. Okay. So, tingnan nyo to class. What's an AR process? How does an AR process behave? Ang AR process class, you base it on the PACF. You look at the PACF, the partial autocorrelation function. If there are significant spikes here, for example, ito, sa lag 1 significant, sa lag 2 significant, no? And then cut off na. Wala nang iba. Okay? That's how the PACF behaves. If it's an AR process, ang PACF may significant spike at some lags, and then meron tayong slow decay, no? Ito, gradual geometrically declining ACF. Okay, so yun yung sinabi dito, gradual geometrically declining ACF and a PACF that is significant for only a few lags. Yan. That's indicative of an AR process. Okay, so pag ganyan class, ay mukhang AR process yung ano natin, yung time series natin. On the other hand naman, pag MA process, ganito naman. Reverse siya. You take a look at the ACF function. MA process shows a gradually geometrically declining PACF. Yung PACF naman yung geometrically declining niya. Yan, tingnan nyo class. And an ACF that has a few significant lags. So ito significant dito, lag 1, significant at lag 2, and then wala na. No? Cut off na. Wala nang ibang significant. Pero yung PACF niya, geometrically declining ACF and PACF. Okay? On the other hand, kapag ARMA naman, yan, tingnan nyo ito class, ARMA. So pareho siyang geometrically declining. Okay? An ARMA process is indicated by geometrically filling ACF and PACF. Yan. Okay? Now, of course, class, ito, mga guides lang yan. Okay? Meron pa tayong tinatawag na ARIMA class, seasonal. Ibig sabihin, may mga significant lags tayo at, kunyari, at every quarter. So mayroon kang significant lag at quarter 1, quarter 2, quarter 3, etc. And this is more difficult to process, no? Yung mga seasonal. Okay? So I leave you class to look at this, okay? But general guidelines lang yan. The good news is that we're not going to make use of that, no? Yung ito, paano natin ma-determine to? Para ang hirap pa kasi may significant spike sila at both ACF and PACF, halos pareho lang. Okay, so paano to? ARMA ba to? AR process ba to? O MA process or ARMA process ba to? Now, the good thing, class, as I said, is it will leave us, hindi natin kailangan to, class, to leave the guesswork from us. Meron tayong tinatawag na auto.arima function. Alright, so I'll share this notes with you. Okay, I want you to write this code. So we're creating this model called model 1. Okay, ito na class. And this is coming from the forecast package. So dapat na-load nyo na si forecast. And the function is auto.arima. Okay, and LAPREP, and then i-trace na lang natin. Kasi si trace is equal to true, ibibigay niya lahat ng steps, no? All the steps. It will tell us how he arrived at the final model. Okay? All right. Then we print that output. Okay, sige. I-run natin to ngayon. Okay, and there you go, class. Okay, before I discuss this, kindly chat, please, if you were able to generate this model. I'll wait for you to chat, please, if you are able to follow along. Okay, good. Okay, thank you. Thank you so much, class. Okay, now, tingnan nyo, class. Let me run this again, class, kung walang trace is equal to true, just to show you. Pag walang trace is equal to true, okay, hindi niya papakita yung mga steps na ginawa niya. It will just give us the final model. Okay? So let me go back, okay, para makita natin yung steps na ginawa niya. Right. So fitting models using approximations. So approximations lang to, class, ha? These are just approximations. So, okay. So in-approximate niya muna, class. Tinitingnan niya, class, kung what if this is ARIMA 22, di ba? Notice, class, ARIMA 202. First, ano yung zero dito sa gitna? It means, class, differencing. Okay? Now, question, class. Bakit zero differencing natin? Eh, di ba nag-difference tayo? Can you please answer that question, class? Why is it that this model tells us that ito zero, class, oh? Ibig sabihin, no differencing. Can anyone please tell me why is it that it states here that there's no differencing? When in fact, di ba what we did was to we used return that calculate, no? Or we used the diff log. Di ba pag diff log, kinukuha yung difference nun? Bakit dito ang sabi, no differencing? Kasi pag 1 yan, ibig sabihin, may 1 differencing. May lag 1 na differencing. What do you think, class? Answer, please. Lahat siya, class, oh. Lahat siya, oh. Yes. Okay, Glenn, paki-explain yung answer mo, please. Glenn, gusto may answer din si Migs. Glenn, gusto mo explain yung answer mo?
From what I understand, sir, is if there's one, you would need to difference it again, which would make the model 222. Which if it's zero, it's only one. Like,
Bakit magiging 2 na?
Because you already transformed the data before the modeling.
Yeah, very good, very good. Yeah. Joseph, is that your answer also?
Yes po, sir. Same lang.
Okay, sige. Thank you. You're correct, no? So both of you are correct. Kasi, class, ano ba yung minomodel natin? Tino yung auto.arima natin? What are we modeling? Ang minomodel natin, class, si auto.arima is our log appret, di ba? So we're asking R to model this. And take note, log appret is already different. In fact, it's already stationary. So ang sinasabi niya dito, zero differencing na to. Huwag nyo na i-difference tong log appret, no? Right? Okay, just to distinguish this, class, no? Tingnan natin if, okay, what if, i-close ko muna to. Just to distinguish, i-model nga natin, class, tong ano. Ang i-model natin, class, yung ano, yung Control Alt I. Okay, ang i-model natin, so I'll just do this. Control C. Control V. Okay, auto.arima. What if ang i-model natin si AP? Yan. Take note, si Apple Cross. Ito yung ano, adjusted prices, di ba? Right? Lagyan natin to ng mod 0. Okay, let's see what will happen kung ang pinapamodel natin are just the Apple prices. I-run natin to, trace is equal to true. Okay. Take a look at this class. Oh, you can now see that ang model dapat may 1 dito. Ibig sabihin dapat may differencing na 1. Now, why is there a differencing needed? Kasi nga, yung AP class, the AP object is not stationary. So, ang sinasuggest dito ni R, dapat ARIMA, whatever, no? Below, it's ARIMA 011. It's ARIMA 011, ang best model ito. Ibig sabihin, ang best model nito, i-difference mo siya, tapos MA yung model. Remember, 0 here is your AR process. Yung 1 dito is your MA process, and the 1 in the middle is your differencing. So this is quite different from the log applet natin kanina, no? Ito. So let me run this again. Okay. So sabi niya, first models using approximations based on AIC, di ba? Based on AIC, ang papatak na ang lalabas na pinakamagandang model is this one. Okay, 679, 688. Lumalabas nga dito, 0 min, no? Okay. Pero, dito class, rinefit niya. Okay. Kasi if you take a look at this class, initially, yung ARIMA 100 has an AIC of 11695. Pero, yung 000, ibig sabihin, walang as is lang, no? As is lang siya, is 11679. Okay? Pero take note, approximations lang ito, ba? So, ang ginawa niya, nag-shortlist siya, tapos rinefit niya yung best model without approximations. So, ang lumalabas dito, the best model is ARIMA 100. Okay? ARIMA 100. And by the way, sorry, ang pag 00 lang pala, sorry, I stand corrected class, no? Ang best model is the one with the lowest AIC. So that's, since negative pala to, no? So it should be the highest negative kasi. The lowest here is negative 695 and not this one. In fact, 001 is better than 000. Okay? So ang pinakamalaki dito na pinakamaliit na AIC is 100. Tapos nag-recalculate siya, ito yung lumabas na value, na computation. Okay? All right. So what's our model now? What is our model class? Tingnan natin names. Ano yung laman ng mod 1 natin? So, ito yung mga names ng mod 1 natin class, no? Right? So marami siyang laman. Andiyan yung coefficient. Let me get the coefficient mod. Mod 1 dollar coef. You can get the coefficient from that. Okay? So ito class yung natin. Ito yung model natin. So how will our model look like, class? Sulat muna natin, what is the ARIMA model? Let's answer this, class. What is the ARIMA model? Copy natin to. So our log AP ret, lagyan natin ng sa log AP ret at time t is equal to Okay. So, ano ko lang class yung yung values kinopya ko. No? So, since this is an AR1 process, remember AR1 process to, no? Our model is I'll complete it, ARIMA 1, 0, 1, 0, 0. All right, ARIMA 100, which means you have an order 1 for your AR process. Remember, this stands for your AR, this stands for your differencing, this stands for your MA process. So the equation class is given by this one. Kasi yung coefficients natin, ito, no? 0.0752 at saka ito. The mean is this one, 0.0091, etc. Plus this one, negative of this one. This is your beta, okay, times log return t minus 1, right? T minus 1 class because we are regressing our Apple returns, okay, ito, based on its past values. Galing ako natin plus. Okay, so let me pause for a while and ask questions, class. May I know if you are able to get it? Give you a few seconds plus to check on your data, check on your model. Waiting for your feedback, class. Thank you. Waiting for the others, please. Good. How about the others, please? Okay, good, good. Thank you. I only got 3 responses so far. Let's wait for the others. Okay, good. Thank you. All right. So after we have, okay, as a practice class, sige, tingnan nga natin kung ano yung model. If we were modeling yung AP, no, ito. No? Sige nga, i-model natin si AP class, no? Practice. Let's practice this. Exercise natin to. What if we were modeling the price? What if we were modeling the Apple prices? Okay? So Apple prices ang inaan natin, model natin. No? Okay, so we created this. Mod 0 is, again, nag-auto.arima tayo. Pero bago tayo mag-auto.arima, okay, tingnan natin class ha. Let's see if it will be easy for us to guess. So, no? Mag-ACF, PACF test tayo. So in your case class, even if you'll be using really you're going to use the auto.arima, still maglagay pa rin kayo ng PACF and ACF ha. Kasi I want you to comment on that, no? I want you to comment on, based on the ACF and the PACF, ano kaya yung ano, no? Ano kaya yung possible na model, no? Okay, I'll put this here. Control D. Okay, so dito ACF ni AP. Si AP yung ano, no? So anyway, hindi ko napapalitan yung ano, yung anyway, ito na lang class. Itong TSM na lang para Control C. Mas convenient kasi yung AC, yung ano, yung TSM na AC. Alright. Okay, this one. So let's plot here the autocorrelation and partial autocorrelation function of AP class, AP. So tingnan natin to. Alright, take a look at this class. Yan, tingnan nyo What is that telling us, class? Slow decay to, no? Yan. Slow decay to. So what do we do with that, class? Yung PACF niya, class, significant lag at 1. Pero kinaya 1. Ang correlation niya 1. Diba, class? It's 1. Right? What does that mean? It's a correlation of the time series with itself. Pero hindi yan ang gusto natin. Ang gusto natin, ang correlation ng time series with its log values. Diba? So ito, indicative that your data is not time series. Kung pinat natin ACF and, your data is not stationary. I stand corrected. Tingnan nyo. So this is a slow decay. So pag ganyan, class, hindi ka makakapag-create ng model actually with drop, no? Okay, so again, buti na lang, class, meron tayong ARIMA. Kasi sa ARIMA, siya na yung it will be the one to difference if there's a need to difference. And true enough, class, here, we were able to see that the model of ito, no? With drift, ibig sabihin parang minto, no? It's an MA1, yan, 011. Okay, 011. So once again, if we Control Alt I1, if I get the names, naglagay ba ako ng model 0, no? Names ni model 0. Okay, and once again, I get mod 0 coefficients. Okay, ito, no? MA siya, no? So ano yung magiging model natin, class, kapag MA? Okay, so let me copy this. Ay, not code siya, but MA to. So yung drift, Control C, at saka yung ito. So how will our model look like? Now take note, ano siya, di ba? Yung ARIMA 0, 1, 0, 1, 1. So there should be one differencing. Okay? So therefore, class, yung ano natin, yung data, yung time series na minodel natin is not AP, but rather it should be difference, okay, I'll call it difference AP underscore P. Okay? So it's our difference AP. Okay, i-define lang natin kung ano yung ano, no? Or we can just put difference na yun na lang, no? Difference AP, where DAP is the difference of your AP. And then this is our constant plus, okay, and then we have let's put it in Greek, epsilon underscore t, okay, and then plus this one, and then times underscore epsilon underscore t minus 1. Okay, there. Okay. Take a look now at our model. So since this is ARIMA 0011, so there's no AR component, there's an MA component. MA component is class a factor of its previous error terms. No? Log 1 lang siya, kaya t minus 1, epsilon t minus 1. Okay? So the error term of this current period plus 0.074, this one, times epsilon t sub t minus 1, okay, plus the drift, plus the constant. Okay, there. All right, so let me pause for a while. We have a few more minutes. I'll give you time, and please chat with me. Chat please if you were able to get this. So sana clear class, no? Depende sa model natin, ha. Kindly chat please. You got it? Alright, definitely hindi natin, may konti na lang class ang titira sa ARIMA process natin, ano? And then ipopost ko yung guards kasi ang continuation nito class yung guards model. Tapos ipopost ko na rin yung yung panel data in advance so that some of you are would want maybe to use next week to do advanced lesson. Okay, ito pinalitan natin to step 8 na to, no? Bago tayo magpo-forecast class, i-check muna natin. Wait, okay na ba class? Okay na yung ano natin? Kindly chat please. If you were able to get yung ano naman, yung Apple, no? Okay, good. Good. All right. Mag-iba ba yung model class kung ang ginamit natin hindi yung log? Kung ang ginamit natin yung discrete returns class. So maglagay ulit tayo dito model for the discrete returns. Kasi ginamit natin class yung log returns. Okay. So auto.arima ulit class. Ito. Control C. So let me just call it model 00. Okay. And yung ano natin, AP, ano ba yun? APRET2. APRET2 na yung discrete returns natin, ano? APRET1 din yata eh. Okay, it's either APRET2 or APRET1. Pareho lang yata to. Or APRET1. Okay, about 00. So using the log returns class, yung model natin, ARIMA 100. Now, kung ang ginamit naman natin is yung discrete returns, yung walang log, tingnan natin class kung ano yung magiging model natin. Our model is pareho lang, no? Pareho lang siya. Okay? ARIMA 100. Magkaiba lang ng konti yung yung AR1 component at saka min. So this goes to show class that hindi masyadong hindi masyadong malaking difference ang log returns at saka yung discrete returns. Mas madali lang i-interpret o mas madali lang i-work through ang log returns. Okay, but the model itself, ARIMA, still the same. ARIMA 100 din, no? 0765 ito kanina. 0752. So just a small difference, relatively small difference between the modeling your apple rep, yung discrete returns, at saka yung log returns. But there was a slight difference. Okay, so it's almost time, class. Now, before you forecast, class, dapat i-diagnose muna natin to, no? So let me just share with you just a few extensions, class. No? Ito, so I'll end in this, class. Paki-copy na lang, class. Okay, and then I'll ipopost ko, class, yung conclusion nito kasi konti na lang naman, no? Alright, so what am I doing here? Okay, ibibigay ko na rin, class, yung forecasting, no? So I'm sharing with you the code for forecasting, but before we forecast, class, kailangan muna i-diagnose muna natin yung yung model natin. Okay, so take a look at this one, model diagnostics. Dito, class, I'm computing yung ACF, no? ACF at saka PACF, or ito na lang gagamitin ko, no? Nung residuals. Okay? Kasi dapat, class, yung residuals, dapat wala nang correlation yan. Okay? So I'm using the autocorrelation here. I'm going to plot it. Take note, model 1 residuals, no? Plot natin. All right. What you can see is meron pang medyo may mga ano pa rin, no? May mga ano pa rin, may mga dito, may mga significant ano pa rin, correlations. Okay? Which means, class, which could indicate that the residuals are i-plot natin, class, ito. I gave this to you, di ba? ACF and the PACF of the residuals. Same lang din to. Same as the above. Okay? Mas malaki nga lang. So may mga significant ano pa rin tayo, class, ano? So this does not look good, class, kasi dapat yung mga residuals natin dapat homoscedastic, eh. You can see here that there are still some significant lags, no? Although nawala ni sa lag 1, meron pa rin tayo some later periods may mga significant lags pa rin. And then this one is very important, class, no? Check residuals natin si mod 1. Okay? And it will give us 3 plots, very important plots. Okay. Ito yung plot ng residuals natin, class. Ito yung ACF, tapos ito yung distribution. Kung normally distributed ba siya or not. Okay? So lastly, class, ito. No? Let me share this with you. Last. Okay. So ARCH-test, class, this is actually now yung susunod na ano. It gives us a test, si apple ret ba natin, okay, if we were using, M stands for yung order ng lag natin, no? AR1, kunyari, no? Let's see ARCH-test 1, class. Okay, I'll explain this again, yung sa ipopost ko na ano, no? All right, so what does this tell us, class? Ang null hypothesis nito, class, is that there is no arch effects. Arch means autoregressive conditional heteroscedasticity. Okay? Now, arch effects, class, pag rineject natin to, yung null hypothesis, ibig sabihin nun, hindi sufficient yung ano natin, yung ARIMA model natin. Ibig sabihin nito, may mga residuals na hindi may mga points na sa atin, may mga data points na hindi nakaka-capture ng ARIMA. And it calls for a Garch model. Okay? So ito na yung next, class, no? Ito na yung next. So kung hindi kaya ng ARIMA model, dapat next step tayo, mag-Garch tayo. Because the ARIMA model was not sufficient to model our time series. All right? So I'm sorry about that, class. Let me